Law of exponents. Let a and b be positive numbers and x and y be real numbers. So the first one is we have the same base, b to the x times b to the y. So they have the same base. The first exponent is x, the second exponent is y. Then overall that equals to b raised to x plus y. So same base, you have two exponents, so all you have to do is to add them. Remember, they must have the same base. And then b to the x divided by b to the y, they have the same base, and then you do b raised to the x minus y. And then the next one is b to the x, and then you raise the whole term to y, then you multiply the exponent. The next one is you have a times b raised to the x, that is equals to a times x, a raised to the x times b raised to the x, and then the last one is a divided by b to the x, that is equals to a times raised to the x divided by b raised to the x. So for the last two, I will just call that both a and b, they both share the x. All right, that's how I call this. So let's use this laws to evaluate the following expression. Let's use color to divide this up. The first one is 2 to the negative 3 times 2 to the 5, right? So this one that follows the first rule, right? They have the same base, and then you do 2, negative 3 plus 5, so that is 2 to the second power, right? Which is 2 times 2, that is equals to 4. If that is a 2 to the negative 2 power, then you have 1 divided by 2 times 2, which is 1 over 4. So that is equals to 4. And then the next one, let's switch color. So you have 4 raised to the negative 1 to the third. So in this case, you will be multiplying the exponent. So that is 4 raised to the negative 1 times 3, so which is 4 raised to the negative 3. So that is 1 divided by 4 to the third, negative exponent. So that is 1 divided by 4 times 4 times 4. That is 1 divided by 64. Just keep that in fraction, don't worry about the decimals. And then the next one, we have the 3 to the 5th. Okay, so let's switch color again. Then we have 3 to the 5th, and then 3 raised to negative 1/2. So we are multiplying, right? They have the same base. Or what if they don't have the same base? The first one is base 3. Let's say the second one is base 10. Then there is nothing you can do. They must have the same base. All right? Okay, then this is a 3, and then 5. 5 what? And then 5 plus, right? So, oh, this one is a multiply. Then you will be doing a 5 plus negative 1/3, right? Oh, 1/2. So that is equals to 3. And then this is 2, then that will be 10, right? Minus 1/2. Then you have 3, so this will be a 9 divided by 2. Oh, that is equals to 3, and then you put the 1/2 right here, and then you raise the whole thing to the 9. Let me make sure. 10 over 2 minus 1 over 2, so 9. Then the 1/2 becomes a square root. You can write like this. You can write a square root 3 and then raise that to the 9, or you can do this. 3, you can put the 9 either inside or outside the radical. Alrighty, then the next one, we have a fraction. Switch color again. We have negative 6 to the 4th, and then negative 6 to the 8. So that is clearly adding the exponent, and then negative 6 to the 10. So we have a negative 6, so multiply, then 4 plus 8. And then the 10th power, so this is a 4 plus 8 is 12, so negative 6, 12, and then negative 6 to 10, top minus bottom, right? So 12 minus 10, make sure they have the same base. So this is negative 6, 12 minus 10, so that is a negative 6 to the second power, which is a 6, negative 6 times negative 6, then you have a 36. All right, and then the next one, you have a parenthesis, 1/2, you raise the whole thing to the 5th, and then you raise the whole thing square. I will multiply the power first, so take the 5 times 2, right? So take the 5 times 2, you get a 10. So you get a negative 1/2, and then raise to the 10. So what is that equal to? So that is equals to, you can do this, negative 1 raised to the 10, and then 2 raised to the 10. So negative 1 raised to the 10 is equals to 1, and then 2 to the 10. Since 2 to the 10 is very large, 1 divided by that is 0. I will just leave leave that as it is. Oh, one more thing. So if you look at if you look at all the problems so far, they have the same base, right? So what about this? Let's say I have 2 to the second power times 4 to the fifth power. So now they don't have the same base. Should I just ignore this and then say nothing can be done? No. Look at the 4. The 4 is equals to 2 square, right? So you can do this 2 square, and then the 4, you keep the 5 outside, you change the 4 to 2 square, and then you can multiply the 2 and the 5. So you have 2 square times 2 times 5 is equals to 10, and then you add the exponent, so that is equals to 12. So when you don't see the same base, you can try this. What if you change the 4 to something that you cannot use a base 2? Then in that case, there is nothing can be done. So if you have a 2 square and then times 3 to the 5th, so since there is no way to rewrite the 2 to the 5th, then this one there is nothing you can do. All right, so let's do the last one. The last one, according to my problem, we have 1 over 16. This is a negative 1 over 4, and then you multiply 27 over 64. You have a negative 1/3. So first of all, I will keep the negative 1 inside. So 1 over 16, raise that to the negative 1, and then you raise the whole thing to the 1 over 4. And then the second one, same things, something similar. Take care the negative 1 first. 27/64. So this is a negative 1, and then this keep the 1/3 outside. All right, so 1 over 16, and then you raise that to the negative 1, right? So you raise that to the negative 1, that means 1 divided by 1 over 16, and then you take the reciprocal of the denominator, then you get a 16. So this is a 16, and then you raise that to the 1 over 4th power. And then same thing for the second parenthesis, to the reciprocal, and then you raise that to the 1/3 power. All right, so the 1/4 power, that is the 4th root of 16, and then this one, they both share the 1/3. The 1/3 means a cube root, 64, and then cube root 27. So we have 2 to the 4 equals to 16. All right, and then we have a 4 to the 3rd equals to 64, and then we have 3 to the 3rd equals to 27. So this is equals to a 2. And then the 64, that gives me a 4. This gives me a 3. Then you have an 8 over 3 as your final answer. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share this video in any social media like Facebook for me. If you are new to the channel, click the subscribe button before you leave, and I will talk to you all in the next one. Signing out.